Yeah, we will move on to the uh, second section, right? So we'll move on to the second section. Fine. Right, so this is a very important question, right? So fine. This is a very important question, which will take a lot of two more questions, right? So fine. So data's in cluster analysis. So what are all the datas in the cluster analysis? So first data is a data matrix. It is a fundamental representation of any input data in data cluster, like our normal table, like our what normal table, our data matrix. We have n rows and p columns. That's what they say. We have n objects, right, and p variables. So this is how they mean a matrix, right? So how we just put it is that we have x1, x2, student name x3, x4, and they have scored marks 1, 2, 3, 5, and 2, 0, and 4, 5. Our normal matrix is an example for this. It's our normal matrix is an example. This is the first type. It is called as data matrix. And the second very important type, listen very carefully, important two more question it is. What do you mean by dissimilarity matrix? First one is data matrix, second one is dissimilarity matrix. Listen very carefully here how to write a dissimilarity matrix is that what do you mean by dissimilarity? When I'm going to compare the data and find out the dissimilarity. So I'll write here. So how I'm going to find out the dissimilarity is there? I'll write x1 is there, x2 is there, x3 is there, and I've got x4. These are my four datas that I have, and I'll put x1 here, x2 here, x3 here, and x4. Likewise, it moves on. Listen very carefully here. I'll put when I'm going to compare and find out the dissimilarity. Very important, but I said similarity and dissimilarity. So D stands for dissimilarity or the distance, right? So dissimilarity. So I'm going to compare x1 and x1. It's going to be 0. When I compare x2 and x2, it is going to be 0. When I compare x3 with x3, it is going to be 0. When I'm going to compare x4 with x4, it's going to be 0. That's why you can see all the diagonals will be zeros here. All the diagonals will be zeros. So x minus x1 is 0, x2 minus x2 is 0, x3 minus x3 is 0, x4 minus x. So what do you mean by dissimilarity matrix is that, listen very carefully here. I'm going to, so this place is, I'm going to compare x1 and x2. So what I'm going to write here, I'm going to compare x1 with what? X2. So x1 is here and x2 is here. So what is there in x1? In x1, it is 0. Fine. Right. So I'm sorry. Uh, x1, I have 1 is here. Fine. And x2, 3 is here. Right? So what I'm going to write is that 3 minus 1 will give me the answer 2. Fine. Then 5 minus 2, x2 minus x1, I'm just subtracting. 5 minus 2 will give me 3. So I'm going to add this number 2 plus what? 3. So the answer is 5. So this is very important thing in clustering. The dissimilarity between x1 and x2 is what? 5. So this is what I have just given here. Yeah. Then what is this section talks about? The dissimilarity between x1 and what? x3. So what is the dissimilarity between x1 and x3? Look here. So this is 2 minus 1. It is 1 here. Dissimilarity, right? And here it is 0. Here it is 2. So you have to just take the absolute value. So 0 minus 2 is minus 2. We will take only the absolute value. So the difference between 2 and 0 is what? 2. So it is absolute value. So 2 plus 1 is what? 3. So we have to write 3 here. We have to write what more? 3 here. So that's the dissimilarity between x1 and what? x3. Dissimilarity between x1 and x3. So here you can just calculate the dissimilarity between x2 and what? X3. So what is the dissimilarity between x2 and x3? Look here, here it is 2, right? Here it is 3. So I'll put 1 here first, right? Then here it is 0, right? Here it is 0, and here it is what? 5. So 1 plus 5, it is nothing but what, ma? 6. So this is what I just given. You can just calculate the dissimilarity between x4 and x1. So this is what dissimilarity is all about. So this is the dissimilarity matrix. So very important word that you need to understand. When you have same values, you will get the answer what, ma? 0. So see, for cat and cat, the dissimilarity is going to be 0, right? So when the dissimilarity is 0, which means the data is the same. So that is the help of this matrix known as dissimilarity matrix. You can just understand why diagonally it is coming 0 0 0 0 0. This is the important point. So don't break your head. Just understand this section, which will become 0 when you have the what mass same data. It is how the second important 2-mark question called as dissimilarity matrix, the second different type of what data. So this is 0 0. You can see the diagonal 0 dissimilarity. So what do you mean by dissimilarity? It is 0 means with both the values are what same. Then we have interval scaled variables. We have continuous measurements of roughly linear, which will keep on what changing, even all the variables with equal weight, where we can just standardize this interval scaled variables. When a group of variables is there, we can just find out the standardized measurement. Z score can be calculated and mean absolute deviation can be calculated. This is a second third type of data. Then we'll be having binary variables in clustering. Binary variables will take two values, one will be 0 and another one is what? 1. So in this binary variables itself, there are two different classifications. One is symmetric binary variables. Listen very carefully here. What you mean by symmetric binary variables is that, see, if all the males are represented as 1 and females are represented as what, ma? 0. So either you represent by 1 or 0. So what is the idea here is that uh, both the values, 1 is also important and 0 is also important, because you just specify two important values. One is male and another one is female. When you have a data of binary values of this nature, you call them as symmetric binary variables. Both are equally important. 50% of male and 15% of what, ma? Female. How do you find the dissimilarity between this 0 and 1, right? In a data point I and j, and this is the formula that you need to what? Study. So yeah, 2 more question. And then the second type is asymmetric binary variable. That's what I said. Asymmetric binary variable. The second type, see, HIV positive, HIV negative. One value will be represented by 0 and another value will be represented by what? 1. Here 80 percentage 80 percentage will be 80 percentage will be having HIV what, ma? Negative, right? HIV what? Negative. You only will have a positive. In this case, you have zeros and ones. Listen very carefully here, where both are completely what, different. Both are completely what, different. This is very important and this is not very important. They are not equally important. When you have this kind of variables, it is called as what, ma? uh, Asymmetric binary variables. Symmetric binary variables, asymmetric binary variables. And to find the dissimilarity, right? Very important word. This is the formula, right? So just take it down. Next one is nominal, ordinal and ratio scaled variables. What do you mean by nominal and ordinal? Listen very carefully here. Ordinal values are variables which will have an order, like 0, 1, 2, 3. It will have an order. For example, here they have given an example here, discrete ordinal variables. First you have to become assistant professor, then associate professor, then you will become a what? Professor. Education level, high school, bachelor's and master's. Likewise, you will have an order. While nominal variables, you don't follow any order. Don't follow any order. It will not follow any order. Like values of red, yellow, green, and blue. Right. So fine. So So this is the dissimilarity formula for nominal what variable. So these are the different types of variables, and finally you have ratio scaled what mark variable. So the second important 2 marks. So don't worry about this two sections. Just prepare yourself for the 2 mark questions. Different types of data in clustering. Thank you.